In this course, I will teach the basic graph theory. So I'll mainly follow this book, Introduction to Graph Theory by Douglas B. West. So firstly, we'll know what is the definition of a graph. So a graph is a pair V comma E when this V is a non-empty set, that is V is non-empty, and this E is a multiset of one subsets and two subsets of V. Now what is multiset? Multiset is something similar to a set, but here the elements may be distinct. In case of a set, if A be a set, then the elements of A are distinct, that is the elements will be of the form like this, when this A, B all are distinct elements. But in case of multiset, the distinctness is not necessary, so there may be some elements repeating. Okay, so it is a multiset, but it is not a set, as this A and this A are not distinct elements. So that is the difference between multiset and set. Now A set is basically a multiset of one subset and two subsets of V. Now what is one subset? For example, for this set A, here this A is a one subset, and this A comma B, if we consider, it is a two subset. Okay, so now we'll know what is vertex set and edge set. So basically this V set is vertex set and this E set is called edge set. And the elements of this vertex set, the elements of V are called vertex or vertices in plural form, and elements of this set E are called edges. Okay, so now we will consider some examples to get some clear concept on this. So our first example is very much simple. Let us consider this graph, a singleton vertex. So let us call it V. So here the vertex set is V, and here the edge set is basically an empty set. So edge set may be empty set. Okay, here is no constant that the edge set cannot be empty set or something. So but the vertex set is always non-empty, so there must exist at least one vertex. So this is the simplest graph, and this graph is actually the null graph. Now our next example is also on a single vertex, but there may be some edge. Okay, so our next example is this one. So here also the vertex set is singleton V, but here the edge set we are considering that set. So here the edge set is a one consisting of a one subset, so this one. Now here this one subset, this V, is actually an edge, but here since there is only one vertex, this edge has only one vertex, so both the end vertices are same, so it is a loop. It is called a loop. This structure is called a loop. So, and also now our next example is like there are two vertices U and V. So the vertex set is U and V, but here let us consider that the edge set to be this one, U comma V. Okay, so here the edge, this type of edge we call it edge, and this type of edge, one subset, we call it a loop. Okay, so now this was our G3, and now we will consider another one, say with three vertices U, V and W, and here there are some loop, and also in between V and W there are two edges. Okay, so here the vertex set is U, V and W, and the edge set is, we can see that there is a one subset called U, there is a two subset UV, there is another two subset UW, another two subset VW, and another two subset VW. So it is a complete example actually. Here we can see that there are one subset, there are two subsets, and also there are multiple two subsets, like VW is twice there. So it is a multiset of one subset and two subsets of the set V. Okay, so this example is very much important. So now we'll know what is adjacency and what is incidence. So for this we firstly consider a graph, say this one. Okay, and then we will consider that what is adjacency and what is incidence. So two vertices u and v belongs to the vertex set of G, then u and v are called to be adjacent if and only if u comma v, this edge belongs to the edge set of G. Okay, if this two subset is in the edge set of G, then we call that this u and v are adjacent, and if they are, if this edge is not there, then we call that u and v are not adjacent. Okay, so for example, here all the vertices we can check that u is adjacent to v, u is adjacent to w, and also v is adjacent to w, v is adjacent to u, and all are actually here mutually adjacent. So and we denote it by a notation like that, u is adjacent to v. And what is now incidence? So if we name these edges to be e1, e2 and e3, okay, then we call that an edge e is said to be incident on a vertex v if v be an end vertex of E. Okay, so what is end vertex? If this be an edge E and these two vertices be u and v, then this u and v are called the end vertices of this edge E. Okay, so for here now let us consider what are the incidents. So here this e1 is incident on u and w, and e1 is not incident on u, and here this e1 is incident on u and v, but this e1 is not incident on w. Okay, because this w is not an end vertex of this edge e1. So here e1 is incident on u and v, but not w. Okay, so this is an example. Now we can consider another example. Let's say g1 g2 when this and it is g1. So now we will consider another example g2. Let's say this one. Okay, this one, u, v, w and x. So here u is adjacent to v, u is adjacent to x, but u is not adjacent to w. Okay, and also here this set, if we name this edge to be E, so E is incident on u and v, but not with w and not on w and x. Okay, so now the adjacency and incidence is clear to us. Now we'll know what is degree of a vertex. Okay, so what is degree of a vertex? So degree of a vertex is basically the number of edges, actually number of edges incident on a vertex. Okay, so we are considering this example again. Okay, so g1 was our a triangle type of thing. So this one u, v and w. So here we want to consider the degree of each vertex. So what is degree of u? So degree of u is denoted by d of u or dg of u, something like that, dg of u. So d of u, what is that? Here there are two edges incident on u, u1 and e2. So degree of u is 2. Similarly, degree of v and degree of w are also 2. So now we can consider another example to count the degree of a vertex in a some graph. So let us consider this graph. Okay, so this graph has a loop also. So for this graph, let us say this is u, v and this is w. So simply degree of u is here 2 because there are only two edges, E1 and E2. Okay. Now degree, what is degree of W? Degree of W is also easy to count. It is 3 because 3 edges are there incident on W, and let us call this to be E3 and this is E4. So it is also 3. Now we have to count the degree of the vertex V. So it is little bit tricky because there is a loop. So for if there is a loop, then this loop contributes 2 to the degree of that vertex. Okay, because for a loop we can consider like that both the end vertex of this loop is a single vertex V. So it will contribute degree 2 to that vertex V. Okay, so for this vertex V, what is the degree of this vertex? It is incident on, actually here 3 edges, and for this loop we have to count 2, so total 5. So degree of V is here 5. Okay, so now we will consider a special kind of graph, which is finite graph. So what is finite graph? Finite graph is basically if G be a graph with the pair V and E, that is vertex set and edge set, then this V is called finite graph if and only if both V and E be finite, as the name suggests. So all the graphs up to these we have considered all were finite graphs. But what is infinite graph? Which graph is not finite is called infinite graph. So if the vertex set is infinite, or if the edge set is infinite, then also the graph is infinite graph. So it is not our concern actually in this course. So we will be mainly concerned with all the finite graphs. Now in the next lecture we will consider the first theorem of graph theory, which is mainly related to the total degree of a graph, that is the sum of the degrees of all the vertices is equal to, actually we will see that it is twice the number of edges. So this thing we will discuss in the next class. Thank you for watching me, and please consider subscribing.